Hello everyone, so in this video I want to see how good this process of transforming wood into charcoal is for storing CO2. So I want to see the ratio of stored CO2 by the wood volume, and I was assuming in videos before this one that this ratio would be about 1. So here I've got two wood blocks of 10 by 10 by 10 centimeters. That's about 4 inches. It's chestnut wood, so it's not pine wood. I want to see the ratio of volume of this wood to the CO2 that will be saved or stored inside of that block if it's pyrolyzed or transformed into charcoal. So in fact it's not really 10, it's more 9.5 by 9.5, and here it's 10 centimeters, and the same for that. I will put them on the bottom of my propane tank so that I'm sure they are really completely transformed into charcoal, because these are quite big blocks of wood. When I took out the charcoal from this container, these two cubes broke into pieces and I could not recover all pieces. So I have only a lower bound for this ratio. So I will repeat this experiment, but this time I will make one load with only wood from which I know the volume. So this will give me a more precise answer to my question. So here we got these 3 pieces of wood. I've dried them for about 1 week, and then I put them into the oven to dry them more. You can see this pine cracked a little bit, and this also. I thought this was chestnut wood, but now I think it's oak, and this is oak also. So this piece here is 17 by 2.8 by 5.7 centimeters, and this is about 10 by 9.4 by 9.4, and we'll say that this has about the same volume than this. So now I've got these numbers, and I will just go through the calculations for the smaller piece of wood, and it will be the same for the other pieces of wood, and I will just show you the results of the calculations. So I've got the coal weight and the volume. I will just calculate the weight of the potential CO2 of this coal. So we know that CO2 is composed of 1 atom of carbon and 2 atoms of oxygen, the carbon atom has a specific weight of 12 gram per mole, and the oxygen has a specific weight of 16 gram per mole times 2. So the coal weight, so we will have to multiply the coal weight by 12 plus 2 times 16 over 12 to get the weight of the potential CO2. So that's 11 thirds. It's approximately 3.6. But we will just take 11 thirds. So for that it will be 62.2 grams times 11 thirds. That will give us 228 grams of CO2 that would be released if I burn this coal. Assuming that it is pure coal, which is not true. There are also some ashes and stuff like that in that coal. So now we'll just have to divide this by this, and we'll get the ratio that I wanted to have. So here we got 0.8. Alright, so we have these numbers now, and I get a ratio. I get a bigger ratio than 1 for these two bigger pieces of wood. So only the smaller piece did fully turn into charcoal, and the bigger pieces did not. So I will pass all this material back again through the process of pyrolysis. Here I've got all the material that I recovered, and we'll measure the weight just to see if it's really all or if there's something missing. So this time I will be using that system with an outlet on the bottom and a sheet metal on underneath it, so that the gases will go to the sides and up, and the top is closed. That burned a little bit. So I'll show you all the data if you're interested at the end of this video, but just the ratio that I wanted to have is about 0.8. So that means I got 0.8 grams of CO2 stored in 1 cubic centimeter of wood. That means that if you charcoal half a liter of wood, you can drive 2 kilometers while being carbon neutral. It also means that the calculations that I've done in this video here are quite right. So you need to transform 4 big trees into charcoal to drive 1 year with your car and being carbon neutral. So anyway, I hope this answered your question, and I'll see you next time.